We've done law 1 in the previous video. Just a quick recap. Remember, it's multiplication. When the bases are the same, there's multiplication and the indices or powers are being added. One of the way we can look at this is multiplication is a way that the number gets bigger and you apply the addition to it, another form of making a number bigger. Now we look at law 2. Law 2 states that when the bases are the same, the both a's there, and they are being divided, then we subtract the powers. Now if you look at it, where there is division, that is making the number smaller, we apply the subtraction. That is also another way of making the number smaller. So you know that those two go together. Bases are the same, they're being multiplied, we add. Bases are the same, they're dividing, we subtract. If we look at example 1, we see the bases are the same and they're being divided, so we will apply the subtraction. So this is what we will write as our next step. And finally we arrive at our answer, which is a to the power 3. And remember, there's nothing else we can do to this, so we leave this as our answer. This type of question is a common question whereby learners become confused, because the concept that anything divided by itself and it's identical will always be 1. No matter what you write, as long as it's identical to the top, will always be 1. But we have to prove this mathematically, so let's apply the law. The bases are the same, they're being divided, so our next step would obviously have to be a to the power 4 minus 4. So we would arrive at the answer a to the power 0. Something you must know about a to the power 0. There is an additional law in terms of exponents whereby any number or letter to the power 0 will always be 1. This is a law that must be applied. So if we see a to the power 0, automatically we must know that the law states that this answer must be 1. And therefore we arrive at our final answer, which is 1. Now this becomes a nice way of proving that anything that's identical over itself will always be 1. The next example I've included as numbers and letters. Remember, the bases are the letters. So if the letters were not there, it would be a normal division sum where you have 8 divided by 2, and obviously your answer would be 4 in this case. The bases are the same and they're being divided, so we must follow the rule. But one thing that we must note is the C on its own, or any letter on its own, means that there is a power of 1. And this is a common mistake that learners make in the exams, where they forget that any letter on its own, the power is 1. This will be the next step, and we will arrive at 4C as our answer. In this example here, the 3 over 12 will be treated as normal, and we'll arrive at 1 over 4. But in terms of the letters, the bases are the same and they're being divided, so we have to apply rule 2. So we subtract the powers. Now instead of subtracting 5 minus 8, I normally tell my learners to look at where the bigger number is. The bigger number is at the bottom in this case, so I will put my final answer in the bottom. So I would say 8 minus 5 and I would get the answer 3. So y to the 3 will end up in the bottom because the larger exponent is at the bottom. Using the same technique where we look at the larger exponent, in this particular example it will be 20 divided by 5 is treated as normal, which would be 4. But in terms of the 15 and the 5 for the exponents, the larger exponent is at the bottom. So when we subtract 15 minus 5, z to the power 10 will appear in the bottom. In the next example, using the same principle we've just learned, we can see the bases are the same and they're being divided, so we will apply the rule, which will be law of 2. So a5 and a3, when we subtract them, it will be a to the power 2, and this will appear at the top because the larger number or exponent is at the top. b4 over b4 is a similar example we did earlier, where it's identical and anything divided by itself which is identical will always be 1, so we don't have to write the 1 down. And then thirdly we come to c3 and c5. The c5 is the bigger term, and that's at the bottom, so our C2 will be at the bottom. So let's look at our answer and see how it's presented.